Alright, so our goal here is to figure out the oxidation numbers of each of these elements. So the first one we have is Na2O. Alright, the best way to do this is to take a look at the periodic table. Let's go back to that periodic table. Na is right here. And what he has is, see, if he were Ne, this guy would be happy. But the problem is he's one above that. He's got one extra electron, and so his goal in life is to get rid of that one electron. And so if he gets rid of that one electron, he's going to lose an electron, so that's going to make him a positive one. So the way we look at their oxidation number is, well, that's a +1. And then for the oxygen, this one right here, oxygen is down here. Now, oxygen also wants to get to here. That's this guy's goal. And he has 6 valence electrons. So he's got 6 electrons on the outermost shell. His goal in life, if he could only gather 2 more, he would be happy. And so that's why what he wants to do is he wants to pull in 2 extra electrons. Now, if you pull in 2 extra electrons, that gives you 2 more negatives, and so basically your oxidation number is -2 over there. Now, and for this reason, this actually works out perfectly because there are 2 NAs, making this a, not an oxidation number of +2, but it gives it a total oxidation number, or Na2 has a overall charge of +2, and then that combines with this -2 over here, and then so that makes it 0, which is good because this compound needs to be equal to 0. So there's our oxidation numbers right there. All right, for this H2SO4, all right, we know that H is a +1. And the S, well, here's the thing. You can use this idea that these compounds have to add to 0 in order to kind of figure out what other parts of it is equal to, what other elements are, the oxidation number of other elements are. So we know the oxidation number of O is a -2. Okay? Pretty much oxidation number of oxygen is always -2 unless it's tied with fluorine. But it's not in this case, so we're good. Now, this sulfur could be a -2. Essentially, he could gain 2 extra electrons. Or what this could do, and this probably would happen less often, but maybe it might, is he could, in essence, he has 6 electrons on the outermost shell. He could lose all of those electrons and then basically go down to neon. That would make him happy. Sorry, all of these elements are males, but okay. All right, so S we don't know. And oxygen we do know. Oxygen is -2. Now, one of the things we know is when we add up all of the oxidation numbers in here, that has to be 0. So there's 2 hydrogens, there is 1 of these things that we don't know, and there is 4 of these oxygens. So that means I've got +2 and question mark, and 4 times -2, which is -8. And I know that I have to add them all up to equal 0. So I've got +2 plus question mark -8 equals 0. Okay, so that would be question mark -6 equals 0. And so question mark equals +6. So apparently, all right, so we know the oxidation number of hydrogen and of oxygen, and the one we didn't know of sulfur, well, that's equal to +6. So apparently, with the sulfur, instead of gaining an extra 2, he had the option of losing 6. And in this particular case, that's exactly what he or she in this did.